Bioregion oxidation. Okay. Thermodynamic law. First, thermodynamic law. The energy of unit where cannot be the energy of universe cannot be plus or minus. غير الثيرمودايناميك law. هذا قانون فيزياء. اليونيفير نقصد به احنا شنو؟ جسمنا خلايا تكتسب انرجي، يعني كومباوند يفقد انرجي، فوسفات جروب، لكن اللي يكتسب الانرجي في داخل جسمنا. يعني جسمنا لا يفقد ولا يكتسب بصفة عامة، الطاقة لا تخرج خارج الجسم، هذا المقصود به. الطاقة لا تخرج خارج الجسم إلا لما تخرج الطاقة as heat, then the energy can be lost and our biological system become exothermic. Exothermic, losing energy. When the biological system losing energy, the heat, it is exothermic. Okay. Energy lost by the organism. Endothermic, the energy gained by the human body. Okay. Exothermic reaction, the energy released from the reaction. Endothermic reaction, the substrate gaining the energy, gaining the heat. So there is endergenic and exergenic. And there's genic reaction, exergenic reaction. Endergenic reaction, gaining the energy. Exergenic reaction, loss the energy. Exergenic reaction, and the reaction substrate lost energy. Okay, endergenic reaction, this reaction, the substrate gaining energy. Okay, so energy gain or energy loss. Okay, فلما تخرج energy it's exergenic reaction. لما energy consumed endogenic. يعني مثلا glucose plus ATP. Glucose 6-phosphate plus ADP. هذا endogenic reaction. لكن لو أنا مثلا فوسفوإينول بيروفيت ال ADP converted to ATP and pyruvate, phosphoenol pyruvate to pyruvate. Exergenic reaction. Exergenic reaction. Endergenic reaction, exergenic reaction. Okay. The second law of thermodynamics. Second law of thermodynamics. So, Lorentz law, energy lost equal energy gained. Zero, no change. يعني خلاياك الانرجي اللي تكتسبها تساوي الطاقة المفقودة. هنا هذه داخل السيتوبلازم ولا؟ الانرجي المكتسبة تساوي الانرجي المفقودة. B plus ATP. So no change. A change in reaction, yes. This compound converted to more active biological compound, glucose 6-phosphate. But السيل في حد ذاتها يحدث فيها نقص وفقط في الانرجي. In general هذا مقصود باليونيفيرس. Universe يعني all the organisms. لكن داخل الخلايا طبعا reaction exergenic endergenic. لكن الخلية في حد ذاتها يحدث في داخلها. ف there is no loss of energy. From first thermodynamic law, energy can be lost, cannot be lost, cannot be gained. In all universe. Okay. The second thermodynamic law. Second thermodynamic law, delta G equal delta H minus T delta S. What is the delta G? It's free energy, Gibbs energy. So delta G, it's Gibbs energy. العالم Gibbs. اوكي هذه فيزياء كلها هي طبعا انتم المفروض واخدين الكلام هذا كله من الفيزياء. اوكي دلتا اتش هذه يسموا فيها احيانا فري انرجي. اوكي دلتا اتش انثالبي heat enthalpy. جوجل شوفوا شو معنى كلمة enthalpy. يعني هذا كله المفروض في الثانوية العامة وفي الثانوي مش هنا في الجامعة. اوكي T temperature in Kelvin. درس الحرارة بالكلفن. راح تقيس درس الحرارة صح؟ كلفن. سنتيغراد. اوكي. دلتا اس انتروبي. دلتا اس انتروبي. وهي الراندومنس. randomness. يعني العشوائية كل ما بيكون الكومباوند أو الكونتاكت between substrates very fast randomness ده عشوائية ولا؟ randomness كل ما بيكون solution of cytoplasm there is randomness between substrates كل ما بتزيد probability of reaction randomness تصادم randomness عشوائية حركة بشكل مستمر كل ما بيكون low entropy كل ما بالreaction بيكون very slow. Okay. دلتا جي في الاكسرجينيك رياكشن دلتا جي اندرجينيك رياكشن دلتا جي نلقاها بوزيتيف. الاكسرجينيك دلتا جي دائما بالماينس. اوكي يعني الكومباوند lost energy. يس لما يفقد energy الكومباوند في حد ذاته يفقد بوزيتيف هو يصبح نيجاتيف. دلتا جي ان exergenic reaction is equal minus number. Okay. So when delta G minus, the reaction is biologically active. For example, ATP, delta G of ATP equal 7.3 minus kilo calorie per mole. Okay, delta G minus. Okay. كل ما بيكون الكومباوند الدلتا جي لها بالماينس اعلى من 7.3 كل ما بيكون biologically active compound. So what is the biologically active compounds with this delta G if it's their delta G less than delta G of ATP يعني ممكن يكون minus 14 minus 14 أقل من minus 7.3 لأنه بالماينس. فكل ما بيكون الدلتا G less than delta G of ATP it is biologically active compound. For example, acetyl-CoA biologically active compound more than ATP. Okay. Succinyl-CoA. Succinyl. Phosphoenol pyruvate. Okay. Creatine phosphate. صار احنا يهمنا في قوانين الفيزياء هذه الدلتا جي. Okay. You must know that when delta G less than delta G of ATP, that is mean the compound is biologically active compound. What is the meaning of biologically active compound? Biologically active compound is the compound which can give energy. Okay, so ADP, it is less biologically active compound than ATP. AMP, less biologically active compound. Glucose, less biologically active compound than ATP. Okay. In our biological system, the reactions by which ATP produced is oxidation reduction reactions. reduction reactions. So all the biological systems, reactions in biological system, it is oxidation reduction reaction. Oxidation reduction reactions. So redox reactions in our biological system. Okay. For example, glucose 6 phosphate 2 6 phosphor gluconolactone. Yes, it's oxidation reduction reaction. NAD B to NAD BH. Yes. NAD B to NAD BH. What is the reduction? It is gaining electron. Gaining electron, yes. Reduction is gaining electron. Reduction is a reaction in which the electron is gained. Oxidation. Electron. Loss of electron. Or oxidation, gaining oxygen. Compound bind with the substrate, bind with the oxygen. Electrons can be transported. So electrons can be transported as anhydride. What is the anhydride? Hydrogen with only one electron. So hydrogen minus. Okay. So electron can be transported between substrated as anhydride or as hydrogen ion, or as electron. As electron, for example, iron. Hemoglobin, for example, can gain electron and become ferrous. So ferric, ferrous. Anhydride, NADH. Hydrogen, fast, 2. Okay. Iron can gain only one electron or loss only one electron. So can loss only one electron and can gain only one electron. NAD B or NAD can gain two electrons or lost 2 electrons. Fat can get 2 electrons or lost 2 electrons. Okay. So in our biological system, the oxidation reduction reactions is the main source of ATP. Two pathways by which our biological system can produce ATP. Number one, direct phosphorylation of ADP to ATP. It is substrate level phosphorylation. So two pathway, substrate level phosphorylation, substrate level phosphorylation. Okay, so ATP produced by substrate level phosphorylation, for example, phosphoenol pyruvate to pyruvate, ADP to ATP. So in this case, ATP produced without electron transport chain. Direct phosphorylation of ADP to ATP. Number two, for example, succinate, succinyl CoA. To succinate, yes? Succinate thiokinase. ADP directly to ATP. Yes? Or for example, 1,3-bis phosphoglycerate to 3-phosphoglycerate, yes?
ADP
ADP, ATP. So direct phosphorylation of ADP to ATP. Okay, substrate level phosphorylation. Number two, by electron transport chain. Electron transport chain. And most of ATP produced from electron transport chain when in mitochondria. Therefore, mitochondria is the powerhouse of cells. So the main energy produced from electron transport chain. Okay? Enzyme is involved in oxidation reduction reactions in our biological system. It is oxidoreductase enzymes. Oxidoreductase enzymes. Enzymes involved in redox reactions. All of them are oxidoreductases enzymes. Number one, dehydrogenases. Dehydrogenases. Okay. Dehydrogenases classified into anaerobic dehydrogenase, aerobic dehydrogenase, anaerobic dehydrogenases, and anaerobic dehydrogenases. Aerobic dehydrogenases. Okay. Aerobic dehydrogenases, anaerobic dehydrogenases. Anaerobic dehydrogenases, for example, pyruvate dehydrogenase. Okay, pyruvate dehydrogenase. So no oxygen involved in reaction. ما فيش reaction فيه oxygen. Okay. The dehydrogenases, the electron acceptor is the NAD or FAD or NADP. So electron acceptor, for example, glycerol 3-phosphate. Glycerol 3-phosphate dehydrogenase NAD to NAD H, okay, H plus 2 dihydroxyacetone phosphate. This is oxidation reduction reaction, dehydrogenase. And dehydrogenase enzyme is the electron acceptor, is NAD or fat or NADP. So, electron acceptor is this compound. So, accepting electron reduce it to NADH. Okay, so electron acceptor. So electron acceptor is the NAD or FAD or NADP. NADP, for example, glucose 6-phosphate, oxidize it to 6-phosphogluconolactone. Yes? الفات succinate 2-fumarate, succinate dehydrogenase. So electron acceptor is fat. This is all of these reactions are anaerobic reaction. But oxidoreductase enzymes, for example, so there is substrate, for example, xanthine, converted to uric acid. Xanthine oxidase. So there is fat, H2, but oxygen involved in reaction and converted to H2O2. So this is electron acceptor. In this reaction, the electron acceptor is fat, but all oxygen involved in the reaction. So reaction taking place in presence of oxygen. So this is aerobic dehydrogenase. So in aerobic dehydrogenase, the electron acceptor is the fat, but also the oxygen will oxidize it to H2O2. So oxygen involved in reaction in aerobic dehydrogenase. Class 2 of enzymes, so number 1 dehydrogenases, number 2 oxygenases. So number 2 oxygenases. So in oxygenases, the oxygen will bind with substrate. For example, heme oxygenase. So heme bind with oxygen, double bond. So it's oxidation. So in oxygenase enzymes, oxygen bind with substrate. Okay. 2 classes of oxygenases. monooxygenases and dioxygenases. And dioxygenases substrate bind with two molecules of oxygen. Monooxygenase only one molecule. Okay. Okay, for example, هناخده في الامينو acid metabolism. It is dioxygenase involved in tyrosine or in tryptophan metabolism. Okay, dioxygenases, monooxygenases. Number 3, it is oxidases enzymes. Oxidases enzymes. Oxidases enzymes. An oxidase enzyme is the electron acceptor is oxygen. So this is the fixation of oxygen to molecule. This is the electron acceptor is the NAT. In this class, the electron acceptor is oxygen. For example, L-amino acid oxidase. L-amino acid oxidase, this is the amino acid. LNH2 to the left. L-amino acid oxidase. Or NH2 to the left. So, L-amino acid oxidase enzyme. Okay. The NH2 released as NH3 4 and O2 released as H2O2. Okay, and the FMN reduces to FMNH2, and the amino acid will become keto acid. So electron acceptor is the oxygen. This is the oxidases enzyme. Oxidases enzyme. Oxidases enzyme. Okay? D-amino acid oxidase. This is the L-amino acid oxidase. D-amino acid oxidase, the NH2 to the right. D